Okay, let us start the question 26. Which one of the following is more basic than ethylene? What they are saying is, which one of the following is more basic than aniline? Which one of the following is more basic than aniline? How to solve this question? How to solve this type of questions? Okay, let us take aniline. What is the structure of aniline? Is benzene. Okay, in benzene, NO2 present on it. NH2, sorry, NH2 present on it. Okay, this is aniline, and then let us say benzyl amine. Benzyl amine means on benzene ring CH2, NH2 groups are present. And next, diphenylamine. Diphenylamine means NH are attached with two benzene rings. These are the two benzene rings, left hand and right hand side. And next, third, C, triphenylamine. Triphenylamine means nitrogen attached with three benzene rings. And fourth one is para-nitroaniline. This is the para-nitroaniline. So let us compare the basic nature. Compared to the aniline, these three are less basic. How can we say these three are less basic? Because NO2 is electron withdrawing group. NO2 is electron withdrawing group. This is electron withdrawing group, and similarly these benzene rings also electron withdrawing groups. They withdraw the electrons from nitrogen. These electrons are no more available for donation to the other one. So similar case in B option also. There is only one option, option A. Here benzene ring is electron withdrawing group, no doubt. Here the CH2 group is electron releasing group. So that is the reason why compared to the aniline, benzyl amine is more basic. Benzyl amine is more basic. So that is the reason why the option A is the correct one for 26th question. What about 27th question? Electrolytic reduction of nitrobenzene in weakly acidic medium gives. Okay, electrolytic reduction of nitrobenzene in weakly acidic medium gives. Okay, let us focus the answers. N-phenyl hydroxylamine, and option B nitrosobenzene, option C aniline, option D para-hydroxyaniline. Let us see the answer. On nitrobenzene on electrolytic reduction, on reduction, basically it is get converted into NO2 is get converted into NH2, we know. So weakly alkali, in presence of weakly alkali, you can get aniline. You can get aniline in this case. If it is strong alkali, you can get the product initially like this. Then it is get converted into this one. This is known as para-hydroxy. This is known as para-hydroxyaniline. This is known as para-hydroxyaniline. Para-hydroxyaniline. This is known as para-hydroxyaniline. So here the requirement is electrolytic reduction in weakly alkali, means only it can give aniline. So that is the reason why option C is the correct one. Option C is the correct one. So how can we say? Here the question itself indicates electrolytic reduction of nitrobenzene in weakly acidic medium. Weakly acidic medium gives aniline. Okay. Next, let us see another question. Question number 28. Aniline in a set of reactions yield a product D. What is the D? The structure of the product of D would be, okay, what is the product of D? Aniline on reaction with NeNO2 and HCl, you can get the similar reactions I have written here. Okay, here the reactions. Aniline, aniline on reaction with NaNO2 oblique HCl, you can get NaNO2 oblique HCl, you can get benzene diazonium chloride. This is the product. And benzene diazonium chloride on reaction with CuCN, you can get the product here. This is replaced by CuCN, not CuCN, CN is replaced. So CN is substituted here. Then on reduction with H2 in presence of N2, you can get primary amine. Okay, then on reduction with HNO2, this one is get converted into this one, N2 plus Cl minus. This is unstable, so it is get converted into OH. Okay, this is the way you can remember. You may also remember that NaNO2 plus HCl is equal to HNO2. That is the reason why we have written like this. This one is get converted into this one. So you can remember this point also. NaNO2 on reaction with HCl. Next equation, question number 28 is finished. Next question number 29, what it says. Final product of C obtained in this reaction. This is the reactant. I think the product is paramethylenylene on acetylation. Acetylene means acetic on reaction with acetic anhydride gives A, and on reaction with Br2 in acetic acid you can get B. On acid hydrolysis product C is obtained. How do we can get the product? So let us focus question number 29. Here NH2, here they have taken NH2. Okay, you may write again for better understanding. Okay, this is okay. Whatever it may be, here it is NH2. The whole thing is NH2. Here this is, you may consider it as this one. Okay, this is NHH. This is also known as aniline. On aniline you may write NH minus H plus. Okay, nitrogen is more electronegative than hydrogen, so electron pairs are moves towards it. Then you can get like this. This H plus is attached with this minus 1. Okay, this one is goes to attached with this one, and this plus is get attached with the NH. Then you can get the product like this. This is acetic anhydride. AC2 means AC2O means acetic anhydride. Structure of this is like this. You may write again CH3 C double bond O C double bond O CH3. This is known as acetic anhydride. Okay, this name right like this. This is oxygen is more electronegative than carbon, so it is migrated like this. And this one and this one is attached like this. This plus one is attached with this minus one. You can get like this. Then again, in presence of Br2 and acetic acid, Br2 is generally broken out into Br plus and Br minus. Br plus undergo electrophilic substitution reaction here or here, because this is ortho-para-directing group. NH is ortho-para-directing group. That is the reason why you can get the Br here. Then it was undergoes acid hydrolysis. Acid hydrolysis means water is broken out into H plus and OH minus. H plus is attached here and OH minus are attached here, and then you can get the aniline here. Again NH2 group is present here, and you can get the product is like this. Let us see the answer. C is the correct answer for this question number 29. Next, let us focus another question number 30. Question number 30. Okay, what is the product of the above reaction is? What is the product of the above reaction is? What is the product of the above reaction is? This is the reactant. Cyanide is here on benzene ring. There is cyanide and OCH3 groups are attached on. OCH3 group attached to the meta position to the this one, and then this CH3 MgBr is broken out into CH3 minus Mg2 plus Br minus. Then you may remember how these can attach with this. Okay, let us see. Nitrogen electrons, lone pair of electrons are moved like this, minus. This is 5 electrons only migrates. This is plus, and this group is moved to like this, and this group is moved like this. You can see what happens here. I have written here. And then the attachment of the CH3 group is here, and this one is attached like this. And then you can expect hydrolysis. What they said is on further hydrolysis, acid hydrolysis we have seen here. On acid hydrolysis, what happens? Here the OH groups are present, H plus are there. Okay, on acid hydrolysis means in presence of acid, water is broken out into H plus and OH minus ions. If here there is a 2 bonds, and then 2 H plus and 2 H bonds are observed, then nitrogen is more electronegative than carbon, so this is negative and this is positive. Okay, then 2 OH groups, OH minus groups are attached here, the carbon, and 2 H plus are attached to the nitrogen. Then what happens? You may get like this. You may get 2 OH groups are attached like this. Okay, 2 OH groups. Okay, 2 OH groups are attached like this. Okay, then 2 OH groups for a single carbon is leads to unstable. So simply it is broke down like this, H2O. It can eliminate H2O. Then you may write like this. Okay. Okay. This is the way you can get the product. Okay, let us see the product where it is. Okay, C is the product you can get. Next question number let us stop here.